Hello everyone. Have you ever wondered how computers talk to each other? Like when you send a message or watch a video online? Well, there is a cool thing called the OSI model which makes this communication possible. So think of it like a set of rules that all computers follow to make sure they understand each other. So it's a bit like how we use a common language to communicate with our friends from different places. So, friends, this OSI model has different layers, kind of like a cake, each with a special job to make sure your pictures, your messages, and videos get to where they need to go on the internet. So, today we are going to explore these layers, understand what they do, and how they help us all stay connected in this digital world. So, let's dive in and uncover the secrets of how our devices really talk to each other. Thank you. Hello, friends, welcome back to my channel. So, today we are diving into the intriguing world of the OSI model. One thing I have noticed is that many newbies struggle to wrap their heads around the OSI model. It's like they have got the pieces, but the puzzle is not coming together. So, in this video, I am on a mission to make it crystal clear for you. So, we are going to break down all the 7 layers so that you can confidently use this knowledge in your day-to-day work. And if you are serious about leveling up your skills and gaining some serious clarity, then I would suggest you to stick with me till the end of this video, as we have a lot to unpack in this video. So, starting with the introduction of the OSI model, let's talk about the OSI model. So, starting with the introduction, let's start with the introduction of OSI model. So, OSI stands for Open System Interconnect Model. This model was a game changer when it was adopted as an international standard by the International Organization for Standardization in 1984. So, at that time, network computing was just taking off. The OSI model works by dividing communication into 7 layers. So each packed with various hardware standards, protocols, and services. So each of these layers has its own specific role in handling the data that's being transmitted. So this layering system makes it easier to manage and understand the complex process of data transfer in network environment. So the OSI model is composed of 7 layers, namely the application layer, session layer, transport layer, the data link layer, and physical layer. So, application, presentation, session, transport, network, data link, and physical. So, these are the 7 layers. So, as you can see on the left side, the layers are always counted from bottom up. So physical layer stands at layer 1 and application layer is layer 7. So layers are always counted from bottom up. So if we look at the categorization of these layers, so the first 3 layers, application layer, presentation layer, and session layer, these are the upper layers, also known as software layers. And network, data link, and physical. These are the lower layers, also known as hardware layers. So, friends, the transport layer is positioned in the middle of the OSI model, is often considered the heart of the entire system as it facilitates the reliable and efficient transfer of data between different devices or nodes. So, it plays a crucial role in ensuring that data is transmitted accurately and efficiently, and it functions as a bridge between the upper and lower layers of the OSI model. So, how do we memorize this? So, if you want to quickly memorize these seven layers, you can remember the phrase all programmers should take new development projects, where each first letter corresponds to the names of the OSI layers in order. So, if you look at all, so the first letter is A, which stands for the application layer, and so on. Some of you might be familiar with the other phrase, which is please do not throw sausage pizza away. So, this is again another way to memorize these layers, but this time we memorize them from bottom towards the application layer. So, let's start off understanding the application layer. So, friends, this layer is responsible for providing networking services to the user. It is also known as the desktop layer, and identification of services is done using port numbers. So, what are those ports? So, if you want to understand the ports, so ports are nothing but the entry and exit points to the layer. So, when the data is transferred from one computer to another, the actual flow is like the data first enters the application layer. Some operation happens at the application layer where we talk about the ports and services, and then at the presentation layer, which is the next layer, there again some other operation happens, and so on. It moves through different layers of the OSI model. So, friends, if we want to look at the total ports, so the total number of ports that exist today is 0 to 65535, out of which the first 1024 ports are reserved ports or well-known ports, and from 1024 to 65535, these are open client ports. So, what happens at application layer? So the main purpose of the application layer is to provide access to network resources. So the network layer enables users access to various networking services such as file transfer, email, web browsing by utilizing protocols like HTTP, FTP, SMTP, and DNS. Then again, when we access some web application, authentication is one thing that we need to complete first. So again, the application layer handles the authentication and authorization processes for users accessing the network resources. So this is something that you should be knowing about application layer. Additionally, application layer also performs functions like supporting communication between distributed applications. So it enables communication between different distributed applications running on different devices, allowing them to exchange data and information seamlessly. So let's understand through an example. So example, you want to access my blog site. dhananjayan.com. So what you'll do is you'll open the browser and enter the URL, that is Uniform Resource Locator, the URL of my blog site. So here what happens is your computer would create an HTTPS request and will send it to the web server. So here the client means your computer, and the web browser, so sorry, the web server is the server located somewhere on the in the data center on the cloud. So what will happen when you enter the URL and hit enter, the request will go to the web server, and the web server will receive your request on port 443, as the request was sent on port on the HTTPS service. So let me quickly go back again and show you. So what I'm trying to do is I'm trying to access the website using HTTPS. So if you carefully look at the address bar, you will see HTTPS being used to access this particular website. So the client will generate HTTPS request. The request will be sent to the web browser. Then the web browser listens to that request on port 443 and responds back with an HTTPS response. So here, once the response is received by the client, your computer is then going to display the website on your computer. So when I say computer, it is nothing but your browser. Here in my case, I'm using Google Chrome. So Google Chrome would be displaying the website within the same. So example, let's talk about FTP. So like HTTP and HTTPS, which is used to access the web pages or accessing the web application. So when the site is in design phase or there are certain modifications required, we use a protocol called FTP, as you can see in the address bar. So FTP is used to actually transfer web pages or documents to, or upload images to your website. So here, same like HTTPS request, your computer is creating an FTP request now, which will be sent to the same web server. So here I have written FTP server. So this is nothing but the same web server, but it is accepting FTP requests as well. So request is listened on port 21, and again the response would be sent back on the same port. So application layer maps these services to specific ports. Example, request HTTP request is sent on port 80. HTTPS request is sent on port 443, and same in the same way FTP uses port 21. So now you can see the site is visible in some different format. Now you are able to see the folders and the web pages on your web server. So this is how the FTP works. So if you want to talk about the activities and the attack vectors, so this particular slide, wherever you see a red box on the top with activity and attack vectors, means we are trying to emphasize on the security aspects about that particular layer. So here, application layer. So activity, as we have understood, user interface and software applications work at this layer. The web browsing, email communication, and file transfer happens at this layer. And the protocols that are used are HTTP, SFTP, FTP. So these are only some protocols that I have mentioned, but there are many more protocols used by different applications at this particular application layer. So what are the attack vectors? So as we all are aware, malware injection may happen at this layer. Somebody may send a phishing email where the person would try to impersonate someone you know, and an email may be received in your mailbox with a link or a suspicious attachment. So that's where again we are accessing the email at application layer. So phishing attacks is another attack vector that works at this particular layer. Now coming to bringing the application down, most of the times attackers target particular URLs or websites where the primary purpose of the DOS or DDoS attack is to make that application inaccessible by sending millions and billions of requests at this particular layer. So this request could be HTTP, HTTPS, or it could be any other protocol which works at this particular layer. So we have understood the attack vectors. Now coming back to the services and ports. So as we already discussed, HTTP service uses port 80. So if you want to access, you can access it in this manner. We open the browser, enter the URL, and the web page is displayed. In the same way, coming to FTP, we send a request using FTP protocol. Again, the web pages are visible in the way you access files and folders on your computer. Coming to SMTP, this is the same thing that we do for accessing our email. So I have tried capturing an example from the browser. So we access email. So here the protocol that is being used is SMTP. Now coming back to Telnet. Telnet again, if you are a network guy, you might already be using Telnet to connect to the routers. So many a times Telnet service is used to check if a particular service is running on a server or a cloud platform. So this was about the telnet. So I hope with this you have understood how the application layer works. So you can take a pause here. So I have captured some of the insecure and secure ports. So on the left side, in the left column, you can see insecure ports. So FTP, telnet, SMTP, time, DNSO, whatever you see in the insecure ports or service column here are the insecure services. So now if you are using these services, I would recommend using the secure ports for these services. Example, FTP is not secure anymore because it sends the username and password using plain text from the client to the server. So nowadays it's a recommended practice that instead of using FTP, we use SFTP, which is Secure File Transfer Protocol, which encrypts and protects the credentials as well as the data that is being transferred between client and the server. So friends, you can pause at this time and go through all these insecure and secure ports. You can make a note of this so that you can refer to them later in your day-to-day life. So with this, we come to the end of the application layer. So data flow from the application layer, if we talk about, so after the data enters the application layer, it attaches the port number, which is nothing but it defines the service which is being used while the client is accessing a particular service, and what is the port on which the server should reply back. So data and application layer now enters the presentation layer. So friends, with this we come to the end of application layer. So let's now jump into presentation layer and understand few more details of the same. So friends, let's talk about the presentation layer. Presentation layer is responsible for converting data into standard formats. So example, as you can see, ASCII, EBCDIC, JPEG, MPEG, BMP, MIDI, WAVE and MP3. These are some of the formats in which the data is uh, converted at this layer. So if we want to understand the functions of this layer, so encoding and decoding, then encryption, decryption, and finally compression and decompression. So these are the three primary tasks which are done at the presentation layer. Example, if you are accessing microsoft.com, you will see an encryption symbol on the lock symbol at the topmost left corner of your address bar. So this is what is the function of presentation layer, where the encryption of data has been done. So friends, presentation layer, which is the sixth layer in the OSI model, primarily focuses on the data formatting and conversion to ensure that information from the application layer can be used by the network and vice versa. Its main purpose is to provide a common language for the application layer, allowing different systems to exchange data. So the presentation layer facilitates the following key functions. So data translation and encryption. So it translates data from the application layer into a format that can be easily transmitted across the network. So we cannot simply, suppose you are chatting with your friend and sending some message. So the message cannot be sent as is from your computer to your friend's computer. So there has to be some operation happening on that data to bring it in a format which can be used to transmit information from one place to another place. So data translation and encryption, so these are the uh, key functions those happen at this particular layer. Again, if there is a huge amount of data being transmitted, example, you are uploading or downloading a movie or a big file in GB, then most of the times, looking at the available bandwidth, your size of the data needs to be compressed or decompressed. So this is another function that is done. Apart from that, we have understood the data encryption and decryption. Now, data formatting and syntax. So here it converts the data from the application layer into a standard format that can be recognized by the network and vice versa. So this includes formatting data into commonly understood structure, ensuring that different systems can interpret that data accurately. So presentation layer effectively prepares the data for the application layer to use and ensure that data is presented in a reliable, readable and usable format for the receiving system. So application layer will attach the ports, the data is now entering the presentation layer, and now once the required operations like compression, decompression, encoding, decoding, and encryption and decryption is done, now the attack vectors, if we look at, so data encoding and decoding vulnerabilities. So there are known vulnerabilities which are associated with encoding and decoding. There are tools available which can read the data even if it has been encoded using some algorithm. Then malicious code injection. Again, while the data is being transmitted from application to presentation layer, there are tools available to inject the code while the data is moving from between these two layers. Now again, format string attack. So it is possible from the browsers using many pen test tools to also format the strings which are supplied during the client server get and post operation. So these are the attack vectors at presentation layer. So with this we complete the presentation layer. Now let's move on to the next layer, the fifth layer, which is session layer. So friends, now let's understand the session layer. As the name suggests, this layer works on the session. Suppose you are connected to a web application or website. So there is going to be a session that is being created while you are accessing that particular website at that point in time, right? So you are updating some form, filling up some information, or downloading something from the remote server or application. Session is maintained, and that session works at this particular layer. So session layer is responsible for establishing, maintaining, and terminating the session. So session ID works at this particular layer. So RPC, remote procedure call, then SQL, structured query language. So network file system, NFS, this also works at the session layer. So the session layer is the fifth layer in the OSI model and is responsible for establishing, managing, and terminating the session, as you can see. So its primary function is to provide services to the presentation layer above it and to the transport layer below it. So this layer acts as a mediator between the presentation and the transport layer. So session establishment and termination. So it establishes, maintains, and terminates communications, communication session between two endpoints, allowing for orderly and organized data exchange. So this process involves setting up, managing, and tearing down the communication sessions, which can include dialog control or synchronization and checkpoint creation for data integrity. So if we talk about synchronization, session layer enables synchronization points within the data streams to ensure that data is exchanged accurately and efficiently between the communicating devices. So this helps maintaining a consistency and integrity of data transmission. Again, we talked about dialog control. So it manages the dialogue between different devices, allowing them to take turns transmitting data and preventing conflicts that may arise from simultaneous transmissions. So again, You might, if you are a database guy, you must be knowing the concept of token management, right? So it controls the token passing process. If this process is used for managing access to the network, so session layer ensures that the data exchanged between the two systems remains intact and in the correct order, even if there is a disruption in the network. So, with this, we have completed the introduction of the session layer. So, let's talk about the activity and attack vectors. So, activity, as we already discussed, it establishes, manages, and terminates the connections, manages session state. Example, if you are in a video conferencing call, in that case, the all the users within the same conference room have to maintain with the session that is being established. So attack vectors. So session hijacking is one of the well-known attacks here. So we have come to the end of the session layer. So data from application layer is submitted to presentation layer by attaching the port number. Then presentation layer attaches the encoding. Then session layer does the encoding, encryption, or compression activity while data is being sent. And the same layer at the recipient's end does decoding, decompression, and decryption activity while the data is being received. So now the data is at the session layer, and with this, it will be submitted to the transport layer. So with this, we complete the session layer. Now let's try and understand the functions of the core layer of the OSI model, which is also known as heart of OSI model. So at the transport layer, so transport layer, which is the fourth layer in the OSI model, is primarily responsible for the end-to-end communication between source and destination hosts, so ensuring that data is delivered reliably, accurately, and efficiently. So the transport layer facilitates the following key functions. So identification of services, multiplexing, demultiplexing, segmentation, then sequencing and reassembling, error correction, and finally flow control. So when we talk about the segmentation, so it breaks down the large data streams into smaller segments for efficient transmission across the network and resembles them at the destination. So this segmentation process helps in managing the flow of the data and optimizing network performance. So there could be a situation where you may not be having a consistent bandwidth. Unlike lease lines, when we talk about the broadband internet connection, it is usually 1 is to 8 ratio, where data upload and download speed uh, is not the same always. So for this, data needs to be segmented, that we are going to see in the upcoming slides. So segmentation is nothing but segmenting a bigger chunk of data into small segments. Now, end-to-end error recovery and flow control. So flow control and error correction, these are the two layers, as you can see in the last two options here. So the transport layer provides mechanism to detect and recover from errors that may occur during data transmission. So this ensures the integrity and accuracy of the data. It also manages the flow of data between source and destination to prevent congestion and ensure efficient delivery. So now let's talk about multiplexing and demultiplexing. So the primary function of multiplexing and demultiplexing is to allow multiple applications or processes running on the source and destination to share the network resources by multiplexing data from different applications into a single stream from transmission and demultiplexing it at the recipient's end. So consider a scenario that you are accessing a website. At the same time, you are uploading some data or downloading some data from a website, or you may be listening to audio while you are browsing these websites. So we usually multitask. So multiplexing, what it does is it takes data from all those applications and then multiplexes it to create a single stream of data. And the same data gets demultiplexed on the recipient's end. So I hope you understood the concept of multiplexing and demultiplexing. So let's try and understand how this works. So on the sequencing and reassembling, you will see while we go through the slides. So identifying the service. So there are two services primarily. One is TCP and other one is the UDP service. So people usually get confused between services and protocols. So TCP and UDP, these are the services. Okay. HTTP, FTP, SMTP, as you can see in the last row of the first column here, these are the protocols. Again, DNS, DHCP, TFTP, these are the protocols, but these protocols fall under UDP. So there is a reason why these two services were created. So let's understand them one by one. So TCP stands for Transmission Control Protocol, whereas UDP stands for User Datagram Protocol. So TCP is a connection oriented protocol where the source, if it's sending something to the destination will acknowledge that yes, I have received your request. Now I am responding back to you. Then if you want to send something else again, now you can send it back to me once you receive my response. So this is where you are getting a response from the either end of the communications, right? So that's where we call it as a transmission control protocol, and that's where we call it as connection oriented. So connectionless, it means I have sent some data, but I am not bothering whether the destination has received that data or not. So that's where it's a one-way communication where acknowledgements are not received from the recipient's end. So here under TCP, we receive acknowledgements, but when we use UDP service, we do not receive any kind of acknowledgements here. So acknowledgements being received at this using this service, it is uh, known to be reliable, whereas UDP doesn't give any guarantee whether the data is received at the recipient's end. So that's where it makes TCP look like slower. It works at the same speed as per that of the UDP service, but it's a two-way communication. That's where we are calling this as slower. So in case of UDP, it is faster. So TCP uses port number 6, whereas UDP uses port number 17. Here TCP, where the examples are HTTP, FTP, and SMTP, where acknowledgements are received. Example, you are transmitting some data, you get to see the percentage of data being uploaded, and that is happening because the acknowledgements are being received by the client, and that's where it can very well calculate the amount of data that has been transmitted. Whereas in UDP, example DNS, DSCP, and TFTP, these are the protocols which work under the UDP suite. So, friends, it doesn't mean that UDP is less important because so this is a usual understanding of people. But let me tell you, if the acknowledgements are not needed, then why should we use TCP service? So that is a question, right? DNS, if you look at this service, I just have to resolve the name into IP, right? I need not to bother about whether the requester has got the IP address or not, right? Because there could be millions and billions of requests that a DNS server might be processing, right? So in this case, using UDP makes sense instead of using TCP service. So there are attacks being done on DNS, DHCP, and TFTP. That's where these protocols use UDP service. So that's how they are designed, I would say. And that's where the communication in this world today is more secured. So identification of services we understood. So if we understand the activity and attack vectors, so this layer ensures end-to-end data delivery. TCP and UDP protocols, the services are used. So error correction is again an activity that happens at the transport layer. So attacks now, while the data is in transit, there is a well-known attack called man in the middle attack that is possible at this stage. Then again, SYN and ACK flooding. So there is a request and response. As you are aware now, TCP uses SYN requests, right? So SYN, ACK, and SYN-ACK, these are the requests responses which are received at this particular in this particular protocol. So these can be flooded by using SYN-ACK flooding. Then TCP/IP vulnerabilities. So there are many vulnerabilities that exist at this particular layer. Now let's understand the multiplexing and demultiplexing function. So here, after the data exits from the session layer, transport layer attaches the port number again, where it specifies whether the data is using TCP or UDP service. So to understand the segmentation part, now consider there are two computers on the network. So there is a user on computer A who's talking to a user on computer B. So it could be some messaging software they might be using. So example, user on computer A is sending a message to user on the computer B. So this is the message. So the primary function of the segmentation, the transport layer, is to segment the data. So now the data is being segmented and transmitted to the destination. Now there is a possibility that the user has sent the data. Data has been segmented. It has now been sent to the client. Now it's not necessary that the segments should be received in the same sequence in which they were sent from the source, right? Now the user at computer B has received the data in this format. So when I say user, it's the computer right? Again, the OSI layers on computer B are acting on this particular message. So now you, hello, how are? So do you think that this is the correct way to receive the data? No. So here what happens is these segments before they are sent, there is a sequencing operation which is done on this data. So here as you can see 1 of 5, 2 of 5, 3 of 5, likewise the data has been sequenced and now sent to computer B. Now here at this computer, the destination end, data is now reassembled and then presented to the user on the computer B. So I hope you understood the sequencing and reassembling function which happens at the transport layer. So friends, now let us understand error correction. So example again, the user is sending the data, segments are created and transmitted, the segments are received, but this time there is one segment which is missing. So this segment, now here what happens is computer B will only request for the missing segment to the sender. So here look carefully, only one segment request would be sent back and the source or the sender will reply back with that segment only. And now the computer will be reassembling that on the destination's end. The message is rearranged, reassembled, and now displayed to the user on the destination end. So this is how the error correction happens. Now on the flow control front, as I have already explained, that there is a, if we talk about broadband connection or any other connection, or consider you are using your mobile phone as a hotspot, then the data is not sent on a consistent bandwidth, right? So there is always a fluctuation. You might be in a crowded place and there could be hundreds of other users accessing internet from the same tower to which your phone is connected. There are chances that congestion may happen and some of the segments or data packets might be dropped during the communication. So that's where flow control comes into picture. So computer A is sending data to computer B. Now I'll rewind back. Let me go back once again. So now the computer A is sending data to computer B. 3 windows were sent and now the computer B has received 3 windows. So this process of sending data in the segmented format is known as windowing, where source and destination checks the availability, the destination checks the amount of data that can be transmitted. So now computer B has received all the 3 packets. It will revert back stating that yes, I have received all the 3 window. So now the computer A is trying to send 5 window this time. 5 windows are being sent, but here now only 4 window are received by the recipient. So that means there is a response sent to the source only for those 4 windows. So here the computer A understands that it can send only 4 segments at a time to the computer B. So with this we understood the concept of windowing. Now, understanding the data flow. So, data at application layer is attached with the port number. Presentation layer, encoding, compression, encryption happens. Data is converted in the required format. Session is maintained, created, and maintained at this layer. Now, at the transport layer, there is a transport header which gets attached to the data, and now the data is changed. Now the data gets into the segment format, and that's how it is then submitted to the network layer. So friends, with this we have understood the transport layer. So let's now move towards the network layer. So friends, network layer is responsible for providing best path for data to reach the destination. So logical addressing works on this layer. So router is a network layer device which works at network layer. It is primarily the protocols which are divided into two parts. One is the routed protocols and the others are the routing protocols. IP address, as I said, works at the network layer. So it assigns unique logical addresses to devices in a network, allowing for their identification and enabling the routing of data packets to their intended destinations. So IP addresses are commonly used at the network layer to uniquely identify the devices on an IP network. So routing, so there are two types of routing that happen. So coming to routing, the network layer determines the best path for data packets to travel from the source to the destination, considering factors such as network congestion, distance, and other relevant parameters. So routing protocols, as we see here, RIP, IGRP, OSPF, and EIGRP. These are some of the protocols that we'll be discussing in my upcoming videos. So some of these protocols are distance vector protocols and some are link state protocols. So when we talk about routing protocols, these are the two categories within the routing protocols. So RIP is a distance vector protocol, whereas OSPF is a link state protocol. So to give you a broader understanding, okay, so this might seem little complex to you guys, but one thing I would like to tell you here in the simplest way is that routing protocols define the best path. So purpose of writing routing protocols is to establish the path, right? So example, I am at Bangkok and I'm accessing a website in say Sri Lanka. My request may go to Sri Lanka data center from one of the data centers, one of the routers at Bangladesh, or it could be a situation where my request from Bangkok may land to a Vietnam router, and from Vietnam it may go to some other router and then subsequently to the destination data center. So friends, that is the job of the routing protocols and routed protocols. So RIP, IGRP, OSPF, EIGRP, these are the routing protocols. And when we talk about routed protocols, HTTP, HTTPS, FTP, so these are the routed protocols. So routing protocols establish the path and routed protocols send the data on that established path. So they only deal into sending and receiving the data, but they'll not be looking into the path establishment part. So that is the job of the routing protocols. So let's understand the routed protocols. Example, you are sending some message from a computer with an IP address 192.168.1.1 to a computer with an address as 1.2. So that's what is currently happening at the network layer. As I said, IP addressing or the logical addressing works at this particular layer. So data at this layer is in the form of packets. So as we have seen at the transport layer, data was in the form of segments. Now the segment will become packet at this layer, and now the routed protocol will attach the source IP and the destination IP, and then it will send the request to the destination. So now the destination has received that packet. It will check what is the destination IP. As you can see, it is 1.2, which is matching with the IP address of the destination. Now once receiving that packet, then it will open that packet and will take out the segment to transmit to the next layer, which is transport layer, while receiving the data. Now coming to routing protocols, as I said, routing protocols establish the path. Consider there is a computer on which you are trying to access my website, dhananjayn.com. So the path could be like this, or it may be like this, or it could be some other path looking at the protocol which is being used. Here it could be a distance vector protocol or a link state protocol, basis which the source and destination will communicate with each other. So now once the best path is identified, the website will be displayed to the user. So friends, to summarize the activities at network layer, so routing and addressing is one activity, then IPv4 and IPv6 and routing protocols work at this layer. So somebody may ask you which protocols work at the network layer. So these are nothing but routing protocols and not the routed protocols, right? So example, OSPF is one of those routing protocols. So subnet configuration is again something that goes here. So friends, in my upcoming video, in this particular video series, I shall be uploading some of the videos on the routing and routed protocols as well as IP addressing. So stay tuned to my channel to get further updates. So attack vectors, so IP spoofing, then routing table manipulation, and DDoS attack. These are some of the attacks which can happen at this particular layer. So data at application layer moves to presentation, then subsequently the session layer, then the transport layer. The data is in the form of segment. Now at the network layer, as we discussed, segments are attached with a network header. As we know, source IP, destination IP, right? And the data is now translated into packet, and the device that works at this particular layer is nothing but router. So it could be any router from any manufacturer which understands IP addressing and routing protocols. So devices at network layer are nothing but these are routers or routers. So with this we come to the end of network layer. So let's dive into the data link layer. Thank you. So friends, let's discuss about the data link layer. So data link layer is divided into two sub layers, which are LLC and MAC. So LLC stands for logical link control, where it talks about the WAN protocols, PPP, SDLC, and frame relay. So these are the protocols which go here at the LLC sublayer. And MAC, this is nothing but and MAC, this is nothing but media access control. It talks about the physical address. It is a 48-bit address, that is nothing but a 12-digit hexadecimal number. So friends, uh, it is responsible for the error detection, and devices working on the data link layer are switch, bridge, and network interface card. So you need to primarily focus here on the error detection part, which is the key function of data link layer. So in the transport layer we have discussed about the error correction part, right? So the data, while the segment was missed during that communication, the destination computer communicates back to the source or the sender's transport layer, and the source transport layer corrects the data. But who is it that is detecting that error? So that is what is here we are talking about. So data link layer is the layer which detects those errors, and then it communicates back to the source transport layer. So that is the point and that I wanted to emphasize here. So consider these are the two computers talking to each other. Now here there is a new address which is a MAC address that comes into picture. So now data at the network layer, which is in the form of packet, is now converted to a frame by attaching source and destination MAC. CRC checks are performed. So CRC value or number will be generated. Now if you look here, the CRC number is 33333. Now look at what happens. Now the destination data link layer has received these frames. CRC happened, but the value now is different. So that is why an error is detected. So computer A CRC number was 5 times 3, but while the data was received by computer B, at data link layer, the CRC number that was recalculated was different from the source CRC, and that's where the data link layer contacts the source OSI layers, where it communicates with the source transport layer and requests for resending that data. CRC will again be performed, and then there will be a new CRC number. Data is received, CRC check happened, and now the value, the CRC number at the destination end is matching with the CRC value while the data was sent, and now the frame is translated into the packet and then submitted to the destination transport layer, first the network layer and subsequently the transport layer. So activities at data link layer. So the frames and error detection is something that happens here. Correction requests are sent back. Devices are Ethernet, Wi-Fi, or bridges. So bridges are outdated now, but switches, Ethernet cards, or Wi-Fi access points have the capability to work at data link layer. So attack vectors. So as we know, MAC address, again it is an address. So MAC address spoofing may happen. Somebody may try to assign spoof the MAC address and put the computer on the same network to receive the network responses received by the source. So I'll be releasing additional video on MAC spoofing. So for now, we need to understand that these are some of the attack vectors, including ARP spoofing and VLAN hopping. So the data flow, again, the segment, then packet, and now the data is in the form of frame, and the device that works at the data link layer is nothing but switch. So friends, with this we understood the data link layer. So let's talk about the physical layer. So physical layer is responsible for electrical, mechanical and procedural checks. Data will be converted into binary, that is zeros and ones. As we all know, computer knows the binary language, and data will be in the form of electrical pulses. So if it's a coaxial cable or a twisted pair cable, and in the form of light if it is fiber optic cable. So now coaxial cable is not used in the usual computer communication. It used, but it is still used in television. But uh, for the computer networking, fiber optic is one of the communications or communication channels or the media which is used to transmit data from one place to another. So physical layer, which is the lowest layer in the OSI model, is primarily responsible for the transmission and reception of unstructured raw data between a device and a physical transmission medium such as a cable or wireless link. So devices working at physical layer are hubs, repeaters, cables and modems. So here now we were previously at the data link layer. Now the frame now gets translated into binary data. So now data is actually sent in the form of bits on the network, which is nothing but on off signals. If it is the Ethernet communication, if it is a fiber optic communication, data will be in the form of light. So destination receives it and it takes out the frame. So that is how the physical layer works. So there is nothing much to discuss at this particular layer, but there are few devices that work that we need to know here. So data at network layer is in the form of packet. At the data link layer, it is in the form of frame. And now at physical layer, data is in the form of bits. So hub is now it is an outdated device, but there are other devices which are very well required to make the communication possible, because without any media or physical layer, no computer can communicate with other computer on the network. So the devices at layer 1 are nothing but these are the cables, connectors, so these fiber channel connectors and the category 5 cables, cat 5, cat 6 cables, different connectors work. uh, Sometimes when the signal becomes weak after a distance, there are repeaters which are used. Nowadays these repeaters are also outdated, but there are devices, example switch or hub, which also acts as a repeater because there is a power supply that is enabled in those devices, which then subsequently receives the signal. It could be a weak signal, but they uplift that signal and send it forward. So that's where we have discussed about the function of the physical layer. Now talking about activity and attack vectors. So physical, medium and electrical or optical signaling works at this layer. Uh, Ethernet cables or fiber optic cables are the examples. Sometimes there is a wireless communication. Usually we use Wi-Fi at home or office. So radio waves in this case are nothing but an example of physical layer. So attack vectors again, physical tampering. Somebody may plug in a cable without your notice to your devices or network interface or the information outlet in the office. So that's where physical tampering may happen. Wiretapping is again the same thing where the cable is physically connected to the actual transmission and data is leaked out. Then electromagnetic interference. So most of the times signal jammers or EMIs are used, which actually creates magnetic field around the transmission media. Example, it could be an Ethernet cable, Cat 5 or Cat 6 cable. If somebody puts a high voltage line nearby to the LAN cable, there is a chance that electromagnetic interference that may get created and the signals transmitted through the LAN cable may get dropped during the communication. So encapsulation and decapsulation is something that we'll see. So now on the left side we have source and on the right side we have the destination computer. So while sending the data, the process is known as encapsulation, and while it is received, it is the process of decapsulation. So data from the source OSI layers is passes through different layers. Data is translated into segments, packets, frames, and finally the bits. When the destination receives them, bits become frame, the headers are removed, the frame becomes packet, then the packets are decapsulated. Now the data is in the form of segment, and then session, then presentation and application layer act on it subsequently to make sure the data is transmitted correctly. So friends, let me give you a background behind the name of the technology Ethernet. So we all know that energy and light is transferred from the sun to the earth. And as there is no medium in between, the light or energy shouldn't be actually moving between these two planets. So, but while we know that it is happening, so scientists have assumed that there is a medium called ether luminous, where ether is the name of that medium, given name, and luminous stands for light. So, if we compare ether luminous, or the way energy and heat is transferred between the sun and the earth, data is transferred from one computer to another computer with the same way. So if you are chatting with your friend, right, billions and billions of people are talking to each other, messages are sent across the globe, and this happens at the same time without any error and with the speed same as that of the speed of light. So scientists have removed that luminous word and put networking, the word net. So that's where it became Ethernet, and that's the name given to this technology as Ethernet. So I hope, so I thought I should give you some background. So that's where the name came into picture, Ethernet. So this is again I heard while I was in at the beginning of my career. There are many other stories around it, but this is something I thought I should share with you. So now comparing the OSI with the TCP/IP layers. So the OSI model has 7 layers, while the TCP/IP has 4 layers, where the application, presentation, and session, these layers are combined together in the TCP/IP layers, which is nothing but application layer. Transport layer remains the same. Network layer becomes internet layer in TCP/IP, and data link and physical layer becomes the network access layer. So friends, there is a big confusion that which model came first, right? So friends, while the computer technology was at its initial phase, okay, so if I had to tell you, OSI is nothing but a conceptual model, while the process of development took place, the actually implemented and the model that is in use is the TCP/IP model. But again, the functions or functionalities or activities are happening in the same way, just that to make it more precise to understand, OSI model is considered as a reference model while explaining these communications between source and destination. So these are nothing but the same one, just that here in the TCP IP layers, uh, these 3 layers are combined. So that's where while it was in development, TCP IP is the model which got the traction as compared to the OSI layers. So we already discussed this part. So summarizing, if you access a website, so this is the application layer which is doing it. Example of FTP we have seen, data is displayed in this way. We have seen an example of telnet. Now microsoft.com, if you have access, there is a lock that you can see, encryption. This is the function of the presentation layer. So again, mail we have seen. So with this, friends, we come to the end of the OSI model. If you are still with me watching this video, it means you have had a complete grasp of the OSI and TCP/IP model. In the upcoming videos, I shall be sharing insights on IP addressing, subnetting, MAC addresses, which are part of the OSI layer and which play a very crucial role in the network communication. So, if you are looking out to be a security professional, this is something that you should be knowing. And I hope with this you have had a complete grasp on how the network technology today is working. So, uh, thank you so much for staying back with me. See you in the upcoming videos. If there are some gaps in the explanation, please excuse. But I have tried to compile everything that is available at my outset. I have tried compiling all the thoughts, creating a presentable data where it can be easily understood and uh, used for your future. So, thank you very much for watching this video. Stay tuned and see you in the upcoming vlogs. Thank you.